Officer Turner. I'm in charge of the investigation of the airbag deployment for case 739772. So what I want to run through with y'all today is possible causes of death for your husband and father, William A. Johnson. So, head-on collision. The victim died of blunt force trauma to the head. So what we want to go through is just kind of see what could have happened, see if maybe a faulty airbag system is at fault. So let's go through what we know about these airbags. So we know that in a collision, the crash sensor in an airbag is activated, which sends an electric pulse to the sodium azide. This causes the azide, it heats it up to where it'll combust and decompose into sodium and nitrogen gas. Now, what's important here is the amount of nitrogen gas released. We need 2.71 cubic feet to fill the airbag. What we found out from the manufacturer is that we had 143 grams of sodium azide. This will produce roughly 2.59 cubic feet of nitrogen gas, which is slightly under what we need to inflate it completely. So naturally we assume that the death was caused by underinflation of the airbag leading to head trauma from collision with the steering wheel. But we then found a white powder substance around the airbag and around the driver, which we assumed to be leftover sodium azide, which is highly toxic if introduced to the bloodstream, and a solid in itself which could cause collision and possibly trauma. So what we wanted to do was test the driver's blood for this substance. So what we concluded was that from the blood test that it was not poisoning by sodium azide. We then decided to test the substance to find out exactly what it was. At this point we consulted our chemist and she told us that it was in fact silicon dioxide. Now this suggests that there had to be a second chemical reaction in the process of airbag inflation. So what we know from the first reaction is that the end result is there's always going to be excess sodium left over. It's a highly reactive and potentially explosive metal. So in order to remove this from possible impact of a solid metal to a driver's head, for this reason car manufacturers will introduce compound potassium nitrate along with silicon dioxide in order to remove the excess sodium. We introduced potassium nitrate into the reaction, roughly 34 grams of potassium nitrate. However, this causes excess nitrogen gas to be released in the airbag as well. So what we needed to find out was just how much nitrogen was released in this second reaction. What we found was that 0.13 cubic feet of nitrogen gas was released in the airbag. With this number of cubic feet for nitrogen gas, we did the math, which led us to the second chemical reaction, which is sodium coming together with potassium nitrate and producing potassium oxide, sodium oxide, and our nitrogen gas that filled up the airbag over inflation. Now in the third reaction, we have potassium oxide, sodium oxide, silicon dioxide coming together to produce alkaline silicate glass. Now, this is our white substance. So the sum of these two amounts of nitrogen gas from the first reaction and the second reaction puts us over the limit that it takes to fully inflate an airbag. Now, what we can conclude about this is that something had to go wrong. Either it ruptured, or there was a small leak. Either way, it was overinflated, so something had to break, something had to give. And it happens in a matter of milliseconds. So what this means is that after this overinflation, there's a leak causing the airbag to deflate, which is responsible for the death by head trauma.